So it's converted into kinetic energy. In short, if I draw a box here, same example which we did, and standard example, I'm applying force, box displaced. So this work done is converted into motion.
Yes.
Motion, that is kinetic energy.
Yes.
So work done is stored in a body as kinetic energy.
Yes.
Right. So now, if any, but when this will happen, when there is an unbalanced force. If it is balanced force, this object will not move.
Yes.
Right. If you want to know example, just push that wall which is beside you.
Yes.
Right. If you push the wall is not moving because whatever force you are applying, it is balanced by the object, so it is not able to displace. Once your force exceed, then only that object will move. So
Yes.
force exceed by one side, that means unbalanced. Clear?
Yes.
Even if we go with some spring, same thing.
Yes. Restoring force.
Exactly. Right.
Yes, sir.
So is your concept clear with this work energy theorem?
Yes, sir.
Okay. Shall I directly skip to this collision, or you want remaining potential energy also?
Yes, sir. Collisions.
Collisions, right? You know potential energy, right?
Yes, sir.
Okay. Now, what's collision?
Collision, interaction between two particles.
Yes. Or striking of two things, colliding of two things, right? Or when, like we can say, it's an event when something is about to strike something. Like
Yes.
if we say carom board, right? That's collision of two coins.
Yes.
Not in just carom board. If we go with smallest particle,
Atoms.
atoms. So let me ask you, for collision, do you require physical contact?
No,
As
sir. No, not required.
As I can say, atoms, they don't require, right? But in carom board, yes, they required.
Yes.
So it's not always necessary that it requires physical contact.
Yes.
Okay. So let's talk about collision. Then we'll go 1D and 2D. Sorry, 1D only, right?
Yes.
Only 1D. Okay.
One.
2D you will have in college.
Yes.
Okay. My pen. So first of all, collision. Okay, wait. I've already written that. Let's read that. Let's discuss that. These are the conditions for collision, right?
Yes.
Or we can say some points about collision. So collision is an event of two particles coming together. So there is a mutual interaction between particles.
Yes.
And it should last for finite times, not infinite times.
Yes.
And it might change, not always change its trajectory. It might change the trajectory of particle. Trajectory means?
Direction.
Direction. Yes, direction. So they may or may not be in physical contact.
Yes.
So if we go with this example, we can say gravitation force.
Yes.
Or
Magnetic force.
yes, magnetic force, electrostatic force, right? And like even if we go with the other forces, then also same way. Other force,
Yes.
mechanical force required physical contact. Other mechanical force like colliding of balls, ball and bat, or some other way, right? So example of physical contact: before collision, during collision, they are in physical contact. Collision of proton and alpha particle.
Yes.
So they does not require physical contact,
Yes.
right? So you know what is alpha particle, right?
Yes. Alpha path.
These are also positively charged. These are proton are positively charged. If it is 1e here, 2e. You know this, right?
Yes, sir.
Okay. Shall we move forward?
Yes, sir.
Okay then. Momentum, like in collision, what is the main purpose of collision? Momentum should be conserved.
Yes.
So if why it's not writing? Yeah. If I say delta P, change of force, right? What is
Yes.
force? Momentum by time, rate of change of momentum.
Yes.
So delta force into dt. 0 to t time, P1. If I take P2,
Yes.
delta P2, which is 0 to t F dt. F for 1, 2, and F for 2 to 1. Colliding. These objects are colliding with each other.
Yes.
But in short, momentum is conserved. So what does it mean?
Momentum is
What do you mean by conservation of momentum?
like it is not gained or not lost.
Yes, in short, we can say total momentum or net momentum is
Before is equal to total
constant.
moment. Yes.
If I add both, it should be 0. Total net momentum is 0. That means it is conservation of momentum.
Yes.
Okay. Now elastic and inelastic collision. So elastic, what is elastic first word? What is elastic word?
There means momentum and kinetic energy are conserved.
Yes. But what is elastic?
Elastic means like it there is no change. This momentum and kinetic energy both are conserved. There is an elastic.
Yeah, that is elastic collision. Fine. But what is the word elastic?
Elastic word.
Yes.
Then I'm not unable to just I know but unable to just tell. Like,
Just give me with explanation. I don't want definition. I never ask definition. Give some explanation. Try to give some explanation.
yes, means after collide with same force they go back like that.
Yeah, exactly. So once deformation is removed, it will be in its original place.
Yes.
Right? So how to define this? Ability. It's what is that? It's ability. It has ability to
Restore it.
exactly to restore. Restore to what?
original position,
shape.
original
Exactly.
state.
Yeah. Ability to restore its original shape. Now, inelastic means
So it doesn't have ability to restore.
inability. That is inability.
Yes.
Okay. So elastic collision in one dimension, you will study in one dimension only. So I will not mention that. Elastic collision, so that, as you said, kinetic energy is conserved.
Yes.
That means it does not change with respect to time.
Yes.
In inelastic, kinetic energy is not conserved.
Yes.
So what's the example here? We can say
Elastic.
some billiard ball,
Yes.
right? Or some striking of some two atom,
Yes.
some air molecules to wall, you can see here.
Yes.
Okay. It is not inelastic. For elastic collision, in elastic collision, what is things happening? Linear momentum is conserved.
Yes.
Or we can say law of conservation of linear momentum and angular momentum. Yeah, law of conservation of energies. So energy is also conserved, momentum is also conserved.
Yes.
Okay. What are these energy? Mechanical energy and total
Total.
energy.
Yes.
Yeah. So, but mechanical energy is not converted to other form. So mechanical energy is in mechanical energy form, like
Yes.
kinetic to potential, potential to kinetic,
Yes.
or total energy. Okay, it's not converting to light energy
Yeah.
or sound energy. No, it's not happening there.
Yes.
So all fours are conserved.
Yes.
We know that just now we saw. So, and last one, initial and final particles are same,
Yes.
right? Elastic collision in one dimension.
Yes.
So same thing now, same thing we are doing again. Total momentum before, total momentum after.
Yes.
So for total momentum formula we know, right? M1 U1 plus M2 U2
Is equals
is
to
equals
M1
to
V1 plus M2 V2.
V2. Now, what we'll do here, we'll just take, sorry, M1 term on one side,
Yeah.
M2 term on other side. So M1 U1 minus V1, which is equals to M2, V2 is already there,
Yeah.
minus this one U2.
Yes.
Let's name this the equation number 1.
Yes.
So you were having doubt in this derivation, right?
Yes.
Yeah. So let's derive this. You write with me. It will be cleared. Done?
Yes.
Okay. Don't just take screenshot, you write. Then only you can
Yes.
practice.
Yes.
Yeah. So we saw total momentum. Now let's talk about energies. So do same thing for kinetic energy. I'll hide this.
Yes.
Do it. Get me answer.
This is for what, sir?
Then you said yes.
Means you told to find answer for something that I didn't hear that.
So kinetic energy. Same thing. What we did for momentum. Same thing you do for kinetic energy.
Yes, sir.
What, are you feeling sleepy or what?
Oh, sir, I'm doing, sir.
No. Your voice, like, it look like you're feeling sleepy.
Oh, my voice is originally like that somewhat.
Oh, acha, nice. Then you can be a singer.
Hmm. Option 1. So almost finishing.
Okay.
Done, sir.
Done? Okay.
Yes.
So what are your values? I'm sorry, I just skipped. Yeah. So what you got? V1 and M1 and M2 as? What is left side?
So I got this equation: half m1 into u1 square minus v1 square is equal to half m2 into v2 square minus u2 square.
Then we can do just cancel all half because half is everywhere,
Yes. Yes.
right? Now this is equation number 2. So I'm dividing equation number 2 by 1. Divide this.
2 by 1. Yes.
Yeah. And I can split this as a plus b, a minus b, because it's a square minus b square.
Yes.
I can split this, right?
Yes, sir.
Yeah. Try this and get me next step.
Let's do equation 2 by 1, sir. Yes.
Yes. Equation number 2 divided by 1.
Yes. And equation 1.
Yes.
Sir, I'm almost getting.
Yeah. Good.
I got u1 plus v1 is equals to v2 plus u2.
Exactly. Now, what we want from this equation, what you got from there, make V2 as a subject, remaining thing send other side, and substitute in equation number 1.
So I have to separate v2.
Yeah. From V2, find V2. What will be V2 here? U1
plus
plus
v1 minus u1 plus v1 minus u2.
minus U2, right? Substitute this V2 value in equation number 1.
In equation number 1.
Exactly.
Oh. So once can you show equation number 1? Here I didn't in my calculation I didn't mention the equation number.
Yeah. No problem.
Oh. So, I'm getting m1 u1 minus equals to
So if you substitute in equation number 1,
minus I'm doing this calculation part.
yeah,
Minus 2 into v2. m1 into we got like this m1 u1 minus m1 v1 is equals to m2 u1 plus m2 v1 minus 2 m2 u v2 like that u2
you do.
like that. I'm
Right. Then simplify
confused.
that.
So I'm confused that I have to take m1 common or v1
Yeah.
u1 that common.
Find
What
V1.
common I have
From that, find V1.
to find v1.
Yeah.
Yes, means I got that once.
Easy, right?
Yes,
Just few mathematical steps.
yes, I'm also getting. Two m2 this simplification part is taking some time, sir.
No problem. Take your time.
Minus So I got V1 is equals to U1 into M1 minus M2 plus 2M2 U2 by M1 plus M2 like that.
But you forgot M1 plus M2 with V1 and this one.
Yes, sir, I have this V1 and
Right.
term this isn't even a denominator means
Yeah, you have this term, right? Then okay.
M1
And
minus I have got that V1 is equals to U1 into M1 minus M2 plus 2M2 U2 by M1 plus M2. Like I took a whole denominator as common like that.
oh yeah, that also okay. Fine. Same thing. Now
Yeah,
we
I have
got V1.
I got the same equations.
Yeah, that means same, right? M1 plus M2 is common. I wrote here separately. Okay. Now we got this V1. Now we need to find V2 also.
Yes.
It will be same value because they both are just opposite.
Yes.
Only small change.
Yes.
So what you do, just substitute in this equation which you wrote V2 equals to U1 minus U2 plus V1. Substitute in that. It will
Yes.
be easier to find.
Yes, sir. Yes. Sir, I got this V2 is equal to M2 minus M1 by M1 plus M2 into U2 plus 2M1 by M1 plus M2 into U1.
Yes.
Yes.
Same. Okay. So we got both M1 and M2.
Yes.
So let's see some case. Case 1. If both M1 and M2 are equal, so what will happen? See the equation number, see V1 and V2. Substitute V1 in V1 and V2, M1 equals to M2. That means instead of M2, write M1.
2, yeah. Oh, instead of M2.
Instead of M2, write M1, and we already have M1 there. So something will be 0 and something will be
Just U2 will be 0 whole term and this thing. So I'm doing for a V1. 0 plus. Sorry, U1 terms should be 0. Like 2M1 U2 by 2M. I'm substituting. For V1, 2.
yes, 2.
So I got only U2.
U2, V1 as U2, because other things will get cancelled, right?
Yes, V1 as U2, yes.
And V2?
For V2, I got U1.
U1, because U2 will be 0, U2 side will be 0. U1 means 2M1 by 2M1.
Yes.
It means U1. Now,
Yes.
in the case, if we say U2 is 0, means What do you mean by U2 means 0?
U2 is 0.
After striking, the initial ball velocity is 0.
Yes.
Or we can say, so what is M1, M2, U1, U2. Before collision, after collision, M1, V1, M2, V2. This is after collision, it's collide, whatever happens. That means velocity of second ball is 0. So second ball is at rest.
Yes. Means first body goes back with same velocity.
So what will happen? See that. Substitute value as U2 equals to 0. So what will happen to V1 and V2?
So you have to substitute U2 as 0.
Exactly.
V1 is equals to M1 minus M2 by M1 plus M2 U1.
Yeah. And V2 will be?
For V2,
V1 you found out. Now V2 will be?
2M1 by M1 plus M2 into U1.
Exactly.
Yes.
Now here if I add in same equation just now whatever you said, if I add M1 equals to M2, both masses are same. We are keeping two conditions. Both masses are same and U2 is also 0. Now what you will get as V1? Same condition. Just now what you wrote.
Yes.
Same equation. U2 is 0 as well as M1, M2 is 0. Sorry, equal.
U2 is 0
Because
and M1 equal to
yeah,
M2.
exactly.
U1.
V1 will be?
U1.
Not U1. See, M1 and M2 are equal. That means M1 minus M1. It will be 0.
Yes.
V2 will be 2M1 by 2M1. It will be U1. That what does it mean?
Yes, sir. Yes, sir. Totally
What
0.
does it
V1
mean?
will be 0.
This
0.
velocity, whatever it was initially, it is totally transferred to the second ball.
Yes.
It means that there is no, after striking, velocity of first ball became 0.
Yes.
And total whatever velocity it was at first, XYZ, is total velocity transferred to second ball as V2.
Yes.
Because initially that ball was at 0.
Yes.
Now after striking, this ball became 0. First ball became 0.
Yes.
That means where is other velocity? It went to V2.
Yes.
Even it's proved, right? We got U1 only. V2 equals to U1.
Yes.
Right? Hence we proved also.
Yes.
Understood both the cases, what we are trying to do?
Yes, sir.
Okay. Clear in mind?
Yes, sir.
Both the cases.
Yes.
Right?
Yes, sir.
Now, if there is some more cases, these are small cases. What will happen if it is M1 is more than M2 and M1 is less than M2? Case 3, case 4. See here. Now, we don't need to write, just see. Let's say it's very easy. M1 is less than M2. That means M1 is neglected. So M1 is neglected, remaining terms we will consider. So where is this one? In this case, M1 is neglected. So it is minus U1 because minus M2 by plus M2 into U1.
Yes.
It is 1, minus 1. So it will be minus U1. That's it.
Yes.
In this case, 0 by something. That means 0 only.
Yeah.
Right?
Yes, sir.
Now, opposite of that. M1 is very much greater than M2. That means M2 is neglected.
Yes.
So V1 will be equals to u1. That means nothing is transferred. He is going back.
Yes.
This means the ball, bigger ball, strike, moved back. In this case, the ball strike, nothing happened. Negative velocity. Bigger the mass, less the velocity here. Because it strike and moved back.
Yes.
If what I'm trying to say, opposite ball mass is bigger, and if this ball comes and strike, nothing will happen to him.
Yes.
Right? Or it might move back. Clear?
Yes, sir. Yes, sir.
Okay. So no doubt in this all four cases.
Yes.
Okay. So do you have in syllabus like inelastic collision?
Elastic collision, sir, is there.
No, inelastic. Elastic done. This was elastic collision. No,
Inelastic
inelastic
is not there, not there.
not there. Because there is an inelastic collision here.
Yes.
Then coefficient of restitution. You don't have inelastic for your syllabus, right?
Yes.
Check it. Check it once.
Syllabus. Collisions is prolonged are there in
This for inelastic. I'm talking about this one, inelastic. Collision in 1D.
it's there. Yes, there.
Is there, right? Okay, which board you are in?
Sir,
What is your board? Which board you are studying?
board Telangana.
Telangana. That means it's there. Because
There.
the student whom I taught this thing, it is for Telangana board only.
Yes.
That means even you have. Okay.
Yes.
What, you are tired?
Yes, means almost time is done, sir.
Oh,
I'm tired.
okay.
Yes.
Fine. Then we can have some other day. If you want to just to see here, take a screenshot or something.
Yes.
It's very easy actually. Same thing what we did
Yes.
just now. Same thing we
Yes.
are doing.
Yes.
Shall I go down?
Yes, done. I took the screenshots.
Okay. That's it. This much only.
Yes, sir. Thank you.
Yeah. Same thing. Just try this once. It's very easy. Same thing what we did.
Yes.
Same thing. That's it.
Yes, sir.
Okay. Yeah. Shall I stop sharing?